In this video, we're going to talk about evaluating a definite integral. We talked a little bit about definite integrals last time. And just as a reminder, when I have a definite integral from a to b, a being less than b, of a function f of x dx, I evaluate it by finding the antiderivative of lowercase f using my integration rules, evaluate that at b, and subtract antiderivative of f at a. That's called the fundamental theorem of calculus. So last time we talked about how those can represent areas. And now we're just going to talk about any definite integral between two values. So I have 0 to 2, 5x dx. So I'm going to pull the 5 out. 0 to 2, x dx. Using my rules of integration here, I get 1/2 x squared for my antiderivative. My bounds are 0 to 2, so I have 1/2 times 5 is 5/2, and then 2 squared minus 0 squared. That's 5/2 times 4 minus 0 is 5/2 of 4. 2 goes into 4 2 times, and 5 times 2 is 10. So the antiderivative of that function evaluated between 0 and 2 is 10. All right, number 19 says -1 to 0 of x minus 2 dx. Now I can use some difference rule here, or I can use u substitution and say that the derivative of x minus 2 is still 1. I'm going to do it that way and say that this is going to be 1/2 of x minus 2 squared, and that gets evaluated from -1 to 0. So this is 1/2 of, plug in 0 is -2 squared minus, stick in -1, and that's -3 squared. Will give me 1/2 of 4 minus 9 is -5/2. And just like I told you before, you can get negative answers here because they're not necessarily representing area. If I look at that, the reason that it's negative is this line is below the x-axis here. So I'm talking about -1 to 0. Here I'm talking about this part of the graph, and it's below the x-axis, and that's why it has a negative value to it. So that area would be, let's see, would not even represent anything meaningful to you probably, unless you're considering something like surplus or shortage or something like that. And you would have a shortage here because maybe you would be operating here where you were not supplying enough, something like that. I'm just normally we come up with things in physics where the sign actually determines something with direction. It's not necessarily positive or negative, but we're moving towards or we're moving away, something like that. But you'll probably have things in business where your negative sign is significant in terms of, like, is it something where you have a gain or a loss, something like that. So all right, now I think it's easiest to probably do u substitution here on this one. 4 minus 3t du dt is a -3, so du is a -3 dt. We'll go ahead and take the multiple of -3 there and the multiple of -1/3 out there, -1/3. And then I'm going to have 4 minus 3t to the 2 plus 1 is 3 times the reciprocal of 3 out here is 1/3. I'm going to evaluate all that from -1 to 1. And I get -1/9 of, when I stick 1 in, I get 4 minus 3 is 1 to the 3rd, minus when I stick in -1, I get 4 plus 3 is 7 to the 3rd. So this is -1/9 times 1 minus, and then 7 to the 3rd is 343. Yeah. So we have -1/9 times -342. 342 over 9, and that's divisible by 9. So we have 3 is 27, the remainder of 7, that comes out to be 38. Right? So that's several more problems to look at here. Let's go ahead and look at number 23. 23 is integral from 2 to 5 of x minus 4 cubed dx. So if u is x minus 4, du is 1 dx, so it's already set up there. To use u substitution, just call this 1/4 x minus 4 to the 4th, and evaluate that from 2 to 5. It's going to be 1/4 of, and then stick 5 in there. 5 minus 4 is 1 to the 4th, minus stick 2 in there. 2 minus 4 is -2 to the 4th. This is 1/4 of 1 minus 16 is a -15 over 4. Let's look now at number 25. 25 says -1 to 1 of the cube root of t minus 2 dt. And I'm going to get that this is -1 to 1 of t to the 1/3 dt minus 2 integral of -1 to 1 dt. So this is going to be t to the 4/3 times 3/4, evaluated from -1 to 1, minus 2t, evaluated from -1 to 1. So this is 3/4 of t to the 4/3. Cube root of 1 is 1. 1 raised to the 4th is 1. Minus cube root of -1 is -1. -1 raised to the 4th is 1. Minus 2 times 1 minus a -1 will be +1. So all of this is 0. And then this is minus 2 times 2. That's a -4. Let's look at number 27 now. 27 says the integral from -1 to 0 of t to the 1/3 minus t to the 2/3 dt. We'll split those up. Integral from -1 to 0 of t to the 1/3 dt minus integral -1 to 0 of t to the 2/3 dt. It's going to give me t to the 4/3 times 3/4 -1 to 0 minus, and then this is going to be t to the 5/3 times 3/5, and this is going to be -1 to 0. So put in 3/4. 0 to the 4/3 is going to be 0. -1 to the 4/3 is going to be 1. -3/5. And again, 0 to the 5/3 is 0. And then minus -1 to the 5/3 is going to be -1. So a -1 is a +1. So that's going to be -3/4 minus 3/5. It's going to be -15 minus 12. So that's a -27 over 20. So now at number 29. Two to 8, 3 over x dx. So that's 3 and equal 2 to 8 of 1 over x dx is 3 ln of the absolute value of x evaluated from 2 to 8. It's 3 ln of 8 minus ln of 2. 8 is a power of 2, so that is ln of 2 to the 3rd. That's 3 times 3 ln of 2 minus ln of 2 is 3 times 2 ln of 2 is 6 ln of 2. Let's look at number 31. Zero to 4 of 1 over the square root of 2x plus 1 dx. U is going to be 2x plus 1. Du dx is going to be 2. Du will be 2 dx. Multiply by 2 on the inside, 1/2 on the outside. And I get 1/2. And then this is going to be u to the -1/2 du. Switching to u's, 2 times 0 is 0, plus 1 is 1. 2 times 4 is 8, plus 1 is 9. Changing my boundaries to be limits on u. So this is 1/2 u to the +1/2 times the reciprocal of 1/2 is 2. So evaluate that from 1 to 9. These make a 1. This is 9 to the 1/2 minus 1 to the 1/2. 3 minus 1 is 2. Let's look now at number 33. And this will wrap up this video. Integral from 1 to 2, e to the 1 minus x dx. U is 1 minus x. Du dx is a -1. Du is a -1 dx. So we have -1 and its reciprocal -1. So this is a negative e to the u du. 1 minus 1 is 0. 1 minus 2 is -1. Top boundary is smaller than bottom boundary, so we're going to switch them, and we're going to change the sign. It's e to the u evaluated from -1 to 0, so that's e to the 0 minus e to the -1st. It's 1 minus 1 over e, or e minus 1 over e. Either of those are exact answers. You can use your calculator to approximate that to however many decimal places your teacher may want you to, if your teacher wants an approximate answer. All right, we're going to come back next time, and we are going to talk about finding the average value of a function. That's one of the applications of a definite integral that we haven't talked about yet. So we'll talk about that formula and solve a few problems like that next time to wrap up our discussion of section 5.4. So see you for the next video.